Alright, this is Unit 11, Direct Current Circuits, subunit resistors in series and in parallel. In this video I will be calculating the equivalent resistance for a circuit of resistors in series and finding the current and potential difference across each resistor in the circuit. So, for resistors in series, it's important to note that the equivalent resistance equals the total of individual resistances in the series. So the resistance of R1 plus R2 plus R3 will give you the equivalent resistance of the circuit. It's also important to note that in a series that the current in R1 and R2 and R3 is the same throughout. The current in R1 is equal to the current in R3 the same way that the current in R2 is equal to R3. So there's that. So we have the problem. A 12-volt battery is connected to 4 light bulbs as shown in this diagram here. Find the equivalent resistance for the circuit and the current in and potential across each resistor in the circuit. So in this problem we are given the potential difference is 12 volts. The resistance in the first resistor is 4 ohms, the resistance in the second resistor is 7 ohms, and the resistance in the third resistor is 8 ohms. We need to find the equivalent resistance, the current, and the potential across each resistor. So we'll start by finding the equivalent resistance, which is fairly easy. You just take the resistances of each individual resistor and add them together. So we take 4 ohms plus 7 ohms plus 8 ohms, and we get 19 ohms. Now that we have that, we can find the current across the entire circuit, or throughout the entire circuit, which will be the current in each individual resistor. So we take the potential difference, which is 12 volts, and set it equal to the current times resistance, equivalent resistance, which we know is 19 ohms. So when we work out the problem, we get that the current equals 0.63 amperes. So that means the current in R1 is 0.63 amperes, and the current in R2 is 0.63 amperes. Now that we have the current and resistance in each one, we can find the potential difference in each one. We use the same equation. Potential difference equals current times resistance, and we find the potential difference in R1 is 2.52 volts, the potential difference in R2 is 4.41 volts, and the potential difference in R3 is 5.04 volts. So that is Unit 11.RSP1, resistors in series and in parallel.